Hi guys, today we're going to do word pattern. So given a pattern in a string called s, they want us to find if s follows the same pattern. Here, follow means a full match such that there's a bijection between a letter in pattern and a non-empty word in s. Specifically, each letter in pattern maps to exactly one unique word in s, and each unique word in s maps to exactly one letter in pattern. No two letters map to the exact same word, and no two words map to the same letter. So in example 1, they give us input string pattern equals A, B, B, A, and S equals dog, cat, cat, dog, and we would output true because they tell us that A maps to dog and B maps to cat. So if we have A mapping to dog and then B mapping to cat, then this maps as follows. So yeah, then in example 2, given pattern equals A, B, B, A, and S equals dog, cat, cat, fish, we would output false because A can't map to both dog and fish. In example 3, we're given pattern equals A, and S equals dog, cat, cat, dog, and we would output false because A can't map to dog and cat. So if you guys recall in the last video where we did isomorphic strings, this is basically the same thing, except instead of a character mapping to a character, we're just mapping a character to a word. So for the algorithm, we can basically just split up this string into the words that it is made up of and separated by the spaces, and loop through indices 0 through whatever the length of the string is, and then just check, have a hash map that we are going to check if each character in the map that is a key is mapping to like a word, and just make sure that it's like consistent the entire time. And that's basically how this is going to work. And then we also just need a quick check, since this one does not tell us that the lengths are necessarily the same, so we also just need to add a quick check to make sure that the lengths are the same. So we can start by splitting our string s into, we'll just call it delims for the delimiters, and we'll say s dot split, and we'll split by a space, and then we'll do our length check now. So if pattern dot length is not equal to delims dot length, then return false. And then now we're going to initialize our hash map and start populating it and doing our checks. So we'll say map character to string, and then we'll do our loop. So for I is 0, I is less than pattern dot length, I plus plus, and then we'll just assign char c to pattern dot char at I. Okay, and then we're going to check if we already have this key in the map or not. So if map contains key for character C, so if we already have this character, let's say like character A in our map as a key, then we need to check if the value that it maps to currently is equal to whatever the current character we're at. So like, let's say we already added this A into our map, and then it's going to map to dog. Then when we get to this A, we're going to need to check that this A still maps to dog here at the current index, because this was going to be like index 0, 1, 2, 3. So then this is going to be like index 0, 1, 2, 3. So the character at whatever index needs to map to the word at the other index, or at the same index, but like in the array. So if it contains key, we're going to need to check that it maps to the same word. So if map.getC is not equal to delims at I, then we would return false because that means it doesn't map to the same thing. So map.getC dot equals delims at I, return false. Okay, and then here, so that should be good for this. We're just doing a quick check, make sure it's still the same. So otherwise, if it does not contain the key, then we're going to have to add that as a key. But we also want to, just like in the other one, check to make sure that we don't already have this word in here. Because if we have this word in here, then that's also going to be an issue. So if, because otherwise, like that means that this word already maps to something else that's not this letter, because this letter was not a key. So if map dot contains value, delims at I, return false. Otherwise, we don't have this value in here and we don't have this key in here, so we'll add the key value pair. So then we'll say map.put c and delimZ_I. And then we'll just return true at the end because that means we were able to get through the entire word and the entire array with no issues. So let's run this. Okay, and then time complexity. So we just have this one loop here that is looping through the length of the string. So this is just going to be O of n, where n is length of input string pattern. Well, technically, we'll just say input string because it's technically both of these should be the same, but I guess worst case it's actually no, it's always going to be the same because if it's not the same, then we'll just return false without even entering the loop here. So yeah, so in that case, it wouldn't really matter which one's longer. And then our space complexity. So we just have this hash map that is storing our key value pairs, mapping each character to each word. And that is going to be... Oh, also when I say input string here, or length of input string, so for pattern, that's going to be the number of characters that are in this string, but for S, it's going to be the number of words that are in the string, since we're just looping through each of the words, not each of the characters in the words. Just wanted to make that clear. But our space complexity, so worst case, if every single character and word is unique, then it's also going to be O of n, which is this in using the same n. So that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!